Welcome back, everyone. In the previous video, we learned about the courses or the curriculum or how we can proceed to become an AI engineer. So let's take a glimpse what sometimes an AI engineer does, or what is an AI engineering, machine learning engineering, say computer vision engineer. So today we'll be taking a glimpse by using computer vision techniques to build a fun and a playful thing. Okay, so we'll be building that using computer vision today. So before starting our practical session, if you have any questions related to the project, please type them in the chat box. I will complete the task and then we can discuss your question and answers. Otherwise, we can schedule another session dedicated to Q&A. Okay. Okay. So what will you building? So before getting into the code, let's see what we are building today. Okay. So let's just start it by giving the code. So we run our file. So the file name is canvas.py, and we run our file by using Python canvas.py, so that we can run the file. So we type this in the command prompt where your file is located. We just run the code and let it take a couple of seconds to run. And yeah, so what we're building here, see over here, you can see your hand is getting detected, right? This finger. Now, if we go over here and we just click on clear, it clears the screen on the canvas, which is in the black, right? Now, over here, you can give the signatures. Okay. See, it is using a hand tracking objective. It is doing the hand tracking. Now, you can change the color to green by just clicking on this button. And if you click clear over here and then you do it, it changes to color green. Now, you can change it to red, right? See, over here. Now you can give your signature or do whatever you want to do. So it is a thing which we will do today. So let's see how we are coding it. Okay. So let's just first close this thing, right? So we are using three things. Okay. First, we're using computer vision, which is OpenCV CV2. We are using NumPy, and we are using a MediaPipe library, which is a Google's library, open source library, which we are using. Okay. Now come to OpenCV library, you have to download. So I have given a README file, which is if you see over here, I will give you the GitHub link over here also. So over here, when you run before running the file, you have to write pip install. It is a code to install the packages MediaPipe and OpenCV Python, right? So do that. Now let's jump into the code what we are doing. Okay. So after importing, we are setting the index to blue index, green index, and red index, and an index to 0. Okay. Then over here, what we are doing so over here we are giving different arrays to handle our color points of different color. Okay. So that we are doing over here. Now the kernel to be used for dilation purpose, we are setting up the kernel. Kernel is a certain thing where you set up to do the purposes, and over here you're setting up the color. Now what is 250? It's in RGB. Okay. Now computer doesn't understand colors. Computer understand only numerical format, right? So from 0, right? From 0 it is black to 255 it is totally on the brighter side. So first thing, it's R. You know what is RGB, right? R, G, and B. So R stands for red, G stands for green and blue, and B stands for blue. So over here, if you see, things are in the bracket, right? So it represents first R, then G, then B. Okay. So that's how we are doing the color over here. Okay. Now, after setting up the colors, we set up dev square with white borders. So do you remember when we started our Python code, when we run our particular file, you will see a white box. Let's see. See over here, if you can see, there is a white box. See, you can see a white box. So that's the white box we are building. Okay. So that's this function is doing. We're not getting into the detailed technicalities right now, but we are like, I'm letting you show like what is the fun of learning this. Okay. So it is a playful project, but you can use hand detection in many things. For example, you can make a sand detection model. You can make many other things by using the hand gesture detection, right? So it is just a part, but you can innovate your ideas on implementing it in real life projects. Okay. So right now, what we are doing is we are creating a function which is defining the square with white borders. Okay. So first we are sending the image, then we are sending some other parameters also with border thickness, the color, the size. Okay. So we are doing that, and we are creating CV2. CV2 is an library, OpenCV library, and in that library there is a function dot rectangle. There is a function dot rectangle in that library. We're calling that particular function and we're passing the values. Okay, we're passing the image frame, the which image we are getting. Okay, then we are doing some calculations, and basically it's nothing. X and Y are the coordinates of your hand placement value. Okay, so X and Y are the coordinates basically. You whenever you will see, if we run the code, each and every pixel are the coordinates. Okay, so if you see over here, for example, if this is the thing, it might be coordinate 0 0 comma 0. If this is the thing, it might be 0 comma 1, it might be 0 comma 2, right? If the coordinates over here, if this is 1, then if this is 1 and if this is 1, the coordinate over here will be 1 comma 1. So it will work like that. Okay, so it looks more of like a matrix. Matrix looks like this: 1 2 3 4. Okay, say over here 4 5 6 7. Okay, so this is a matrix. Okay, so for accessing this element, we can say over here, if it is 0, over 0 1 2 3, and over here it's 0 and 1. For getting the fourth element, we say it is in the position of what? It's in the position of 0 comma 1, right? It's in the position of, sorry, it's in the position of 1 comma 0, because it is in the first index, first row, in the in the first index row, and at the 0th index column. So we access the fourth element 4 by giving 1 comma 0, right? So likewise, each and every image has a particular numerical value which ranges from 0 to 255. Okay, if all the boxes say RGB, R is 255, G is 255, and B is 255, it goes up to white. And if everything is 0, it goes to black. That is, there is no color present, right? Like black isn't a color. Black is absence of all the colors. Okay, and if you mix all the colors, you get the white color. Okay, so that's the thing. After we draw the square with the white borders, what we go, so over here we draw the square with the white borders, so we close this particular function. Now let's see what we are doing over here. So before jumping into that, we have to see over here right now that over here we are doing paint window equals to np.0. Okay, let's understand it very in top level view. So it is a code for canvas setup. We are setting up the canvas right now. Okay, what is 30 comma 10? 30 comma 10 aren't nothing but the coordinates. The 30 comma 10 and 110 comma 90 are just the coordinates of that particular cell position. Okay, so what it is saying, key, if we run the code Python, okay, so if I minimize this and if I consider only this, you will see over here it is saying 30 comma 10. So 30 comma 10 starts from here and it ends over 110 comma 90. It 30 comma 10 starts from here and ends till 110 comma 90. So it gives the diagonal, right? And on the base of the diagonal, it is giving me this particular square. Now what it is saying, he also give me the color. So it is given 255 comma 255 comma 255. What are 255? It is nothing but the value of R, which ranges from 0 to 255. Okay, there's a value of G which ranges of 0 to 255. We have given all the R, G, and B values as 255. That is maximize input of R, G, and B. After we maximize R, G, and B's input, we get a white color. So it is nothing but a white color. Likewise, we do same for each and everything. Okay. And after setting up our canvas, we draw the square with white borders, right? Because if we just remove this particular part, square with white borders, we get only the blue, green, and red and yellow. But we need the white borders also to demarcate the particular color in a better manner. So it's a UI part on the end. So after we do that, so after doing that, nothing over here, we are sending the coordinates again, 70, 50, 200, 50. So just sending the coordinates over here, and we are giving the border thickness. So it is a thickness, right? We have given over here, see border thickness. So 3 is the thickness. This is the color. This is the color. Size is 80 for everything. There's a 80 pixel thing. And over here, we're giving the center, like what will be the center of this thing. And over here, we're giving the image. Okay. So this is what we are doing. Paint window is nothing but the particular image we are sending, image frame we are sending. Okay, so this is the image, because NP0 means that there is a pixel value, how much we will get. And over here, NP0 means that everything is 0. Means the NP is a array format, you can say. So if this is the whole array, if the canvas is the whole array, all the array contains 0 values. All the array position contains 0 value. Say if this is the whole array, then all the position contains 0 values. And if all the position contains 0 values, then it means absence of color. Okay. So after we do this everything, then we put text. Okay. We give you a clear, we give you a blue, we give you a green, we give you a red, we give you a yellow. So that's what we are doing over here, right? Obviously, this is the font type we are giving over here. Okay, so we are just giving the, like we are including the text inside these boxes. Okay, now after we do that, now comes the interesting part, which is this particular part. How we detect this particular hand. See, you're seeing all the coordinates over here. So what we are doing over here is we are first calling the function, which is obviously the Google's function of MediaPipe, open source MediaPipe library. After taking up the library, we say, okay, do one thing. MP hands max number of hands is equal to 1. Means that the number of hands, even if I give over here 2 hands, why only 1 hand will get detected? Not both the hands, right? You can see only 1 hand is getting detected, not the 2 hands. So after it detects 1 hand, the minimum detection confidence should be 0.7, which means that the machine learning model should be 70% sure. Should be 70% sure that this is a hand. This is not the face. This is just the hand. So it should be 70% sure. After it is 70% sure, what we are doing, then so this is the setup of the initial setup of the MediaPipe's function. Okay. Now we have done till this. Now obviously it is just the primary part. We have just set up the stuffs right now. But how we can open this camera? See over here the camera is open. So how we can capture real-time data? So for that, what we are doing, we are using the OpenCV model, which is CV2, where we are doing CV2.video capture. We are opening the camera in the real time. After capturing, saying red equals true, means it do capture the particular feed, whatever feed is getting showing, capture the particular feed. After that, there is a particular thing which we are setting up, that red comma frame. So red is true, means it is capturing, and frame means each and every particular thing. So every video is one frame, right? We take frames, we collaborate, and then we get the video. So for now, we are getting each and every frame right now. So every frame is on one picture from a video. A frame means the snapshot or the picture you're getting from the video. So that's one frame, right? So we're taking that frame and we're saying, give me the shape of this frame shape. means what is the size of the frame, right? After we do that, we flip the frame vertical, means we basically like flip it like a mirrored image. Okay, so it's like more of like a mirrored image, so we do mirror it. Okay, after doing that, it is a setup which we have to do to send the data into the media pipe. Okay, so if you read the documentation of the media pipe, you will see that we have to set up like this. Okay, after that we are converting to the RGB thing. Okay, see, where we are doing this thing, frame RGB. After we have completed our setup, then we are ready to send into media pipe. Okay, where it will do the thing. Now it is saying frame equal to CV to dot rectangle. What it is doing, that in this particular frame, in this particular frame, what it is doing, that it is creating rectangles. See, 1, 2, 3, 4. So there are rectangles. See over here, first rectangle, second rectangle, third rectangle. So each and every rectangle is setting up with color. So at first we did it with canvas, but now we have to do it same with this thing, same with the camera. So now what we are doing, we are first creating what? White. White is 255, 255 and 255. Then we create blue. Then we create green. Then we create red. Then we create yellow. So these are the things. If you put the data likewise, you will give the thing. And obviously these are the coordinates. So this is 30, 10. Like from here, 30, 10 is starting. Until here, it is 110, 90. So this is a coordinate, nothing else. After we have set up the frame, the UI part, okay, then what we do over here is CV2.put text. So we put the text clear, blue, green, and red and yellow. So over here, if you see the screen, you will see red, blue, green, yellow. So this is, they are just putting the text over here. Okay. So after we have done with this, then we go to the detection part. Okay. It is nothing. It is what it is doing in a broad hand view, if you understand. It is just taking up the data from this. Okay, it is processing. See, the result is a hand to process the frame RGB. Frame RGB is one frame, like each and every picture. So say this is one picture. This is one picture, right? It is taking up that picture and it is processing it. Okay, after processing it, it is detecting that how many hands are there, and accordingly, if there is one hand, then it is detecting one of the hands, and then it is drawing. See over here, you can see this is dots, this coordinates. So it is drawing this coordinates. Okay, so it's drawing this coordinates. See over here. So if you see, it is drawing this particular coordinates. Okay, so that this particular function is doing. After it has drawn those particular coordinates, now we give the logic, obviously, so that this particular see, the color isn't coming from this particular lip. It is only coming from my first finger, right? From this finger. So we have to code that logic. Without coding that logic, we can't do that. Like, so what's the logic? Let's see. So over here, the logic is like the 4-finger landmark. So it is taking up the landmarks. Okay. So it is first telling which is 4-finger. Okay. So it is a library. Let's check out the library first. So if you see over here, this is the coordinate value. Okay, let me open it in a new tab. Okay, so if you see the image, these are the coordinates. So we are first taking the 4-finger, 8, 0. What is 8? 8 is this. Okay, what is it? This is the 4-finger. 8, 0 means we are taking this particular thing. Okay. So 0, 8, 0 and 8, 1. Okay. So likewise, we are taking the first the 4-finger mark. Then we are taking the thumb mark. Okay. Likewise, we are doing it. So what is the logic over here we have implemented is that over here, if you see, if I do this, my color isn't getting generated at much. Okay. If you see, if you closely do like this, it won't do any color. That means it is acting like an eraser, not, but it's acting more of like a hold that particular ink. But if I'm doing this, it is generating it. So this is the logic which we are implementing, and whenever it is going to see over here, so over here thumb 1 minus center 1, so it's the logic of deducting the cells, deducting the coordinates, and after getting the deduction, we do append with the blue index that yeah, there is a blue index. If it goes to the blue part, if it is going to the blue part, then increment that blue index to 1. If it is going to the green part, then increment the green index to 1. Accordingly, it goes to the yellow index. Okay. After it does that, then what we are doing, then we are just using the, then it is a setup of the color button. Then we are it is set up the color button, and then we are doing the clear button. Okay. For whenever the coordinates coming between 30 and 110, whenever the coordinates are coming between 30, this is 30 and this is 110, when it is coming between these things, it is removing the color. So this is the particular part. It is saying me in that particular whole canvas, in this particular whole canvas, give all the values to 0, means reset those values. Okay, so we are resetting those values. Okay, we are doing by removing the color. What we mean is we are resetting all the values, whatever values we give. So whenever the color is getting drawn, it means that this pixel value is getting changed, that color number. Okay, what is blue? Blue is nothing but 255, 0, 0. Oh, R is 55, 0, 0, right? So we are looking like that. So over here, whenever doing like that, so this particular pixel value gets changed to 55, right? So that particular pixel value is getting changed to 250, like the R is getting to 255, or when the G is getting to 255, or the B is getting to 255. Okay, so that particular pixel value is getting changed. So if you remove those pixel values to, again, you set into in normal positions, like you reset those colors, so it would have any impact. So, and the canvas will get cleared. So that's the logic we are implementing right now. Okay, so that's the overview of the logic we are doing it over here. Okay, and after we have implemented those things, we are doing cv2.line. It is nothing but creating a line. So this particular function OpenCV cv2 is an obviously the open source function which we use, cv2, and dot line is the function. So cv2 is the library and dot line is the function. So for drawing this line, we need the line to be drawn, right? So we are using cv2.line to draw the lines from points. So we take the landmark position. So using the media pipe, what we do using the media pipe, it is taking the position. Say the position is in this particular part. So it is a pixel value. So it starts from this particular pixel value and it ends say from, it starts from here and ends till here. So it's ending to this particular coordinate. It started from this coordinate, it's ending in this coordinate. So it's tracking like that. Okay. After you do that, then you're doing just the same thing in the paint window also. So first you're doing in the frame. Frame means in this particular frame you're doing, and paint window means in this particular canvas you're doing. Like the canvas thing is getting shown over here, right? And after we have completed all the thing, then we just cv2 I'm sure whatever image we have got till now, after pre-processing, after processing it, we show it by giving output comma frame. Output is nothing but the frame's name. If you see, the frame's name is output. Okay, and over here you see the frame's name is paint. So it's the frame's name, and this particular thing is the frame or the picture which we are getting. So yes, that's the thing which we can do by using Python, and it has great implications. So it is just a playful thing which we did right now, but the hand gesture detection is a very good thing which you can use in major projects. Okay, and once you get through the machine learning courses and all, you will understand how to use those things in real life applications, in the real life world scenarios. Okay. So yes, that's it. for the practical session. So if you guys have any doubt, we can address those doubts right now.